Hi everyone. So my name's Jack and I'm a researcher at the Swedish University of Agricultural Sciences. And today I'm going to be talking about some of the work that I did here as a part of my postdoc, investigating how pharmaceutical pollution alters the movement dynamics of brown trout in a large natural lake system. So the contamination of ecosystems with synthetic chemicals is now considered the fastest growing agent of global change. Now, this includes things like pharmaceutical compounds, of which almost 1,000 different drugs have now been detected in aquatic systems worldwide. And worryingly, the problem is getting worse. Indeed, the number of different pharmaceuticals detected each year is escalating, and they're turning up across the globe, including in places like Antarctica. Now, these chemicals represent a unique challenge for ecotoxicology because they're often designed to alter specific biological functions and to be effective at very low doses. Indeed, many of the targets of pharmaceutical drugs are evolutionarily conserved, meaning that they're also present in a variety of non-target wildlife species. However, in our recent systematic map, we found that almost all of the research in this area is done under artificial laboratory conditions that often fail to capture sort of real-world complexity. And these results often assume that drug-induced changes recorded in the laboratory likely affect organismal performance in the wild. But we know that environmental conditions can significantly influence animal behavior, emphasizing the need to conduct more ecologically based research. So we set out to investigate how exposure to a commonly detected psychoactive pollutant, the anti-anxiety and sedative drug temazepam, influence the movement dynamics of brown trout in a natural lake system. So to do this, 2-year-old brown trout were randomly administered with one of 3 different treatments. And this included either a slow-release temazepam implant designed to mimic natural environmental levels, a control implant containing no drugs, or no implant at all, which aimed to account for any effects of the implant itself on fish behavior. Fish were also implanted with an acoustic telemetry tracking tag, which allowed us to monitor the fish's movements and migration success throughout the lake. And following this, all fish were subsequently released into the River Ore in central Sweden, around 2 kilometers upstream of Lake Åsa, where their movements were subsequently tracked. Now, in doing this, we found that exposure to common environmental levels of temazepam significantly reduced the probability of fish reaching the lake relative to the 2 control groups, which you can see here in the first plot. Now, this emphasizes the ability of these drugs to alter animal behavior and movement under wild, naturalistic conditions. But interestingly, however, for those fish that did make it to the lake, we found no evidence of there being any effective treatment on their daily movement rates. So in conclusion, we found that a common psychoactive pharmaceutical pollutant can affect movement patterns and migratory success of fish in the wild, with potential consequences for organismal fitness and population dynamics. So if you're interested in this research, feel free to check out our recent publication in Proceedings B through this QR code. And lastly, I just want to thank the amazing team of researchers who are part of this project, as well as the funders who supported it. So thanks very much to you all for listening. And if you have any questions, please feel free to reach out at one of these links.